Good morning, students. Today we are going to discuss about the corrosion protection techniques. We have already discussed about the problems and their effectiveness, that means consequences of corrosion. Mainly, it leads to the economic loss, production loss, and quality loss wherever it happened. So the main thing is how to control the corrosion. Local level, we always follow the painting over the corroded part, but in the higher, bigger industries and ships, how to control the corrosion, the techniques followed in the corrosion control that we are going to discuss today. Corrosion control can be done by two ways. One is the anodic protection technique, another one is the cathodic protection technique. Today we can discuss about the cathodic protection techniques. In cathodic protection techniques, the metal to be protected is made to act like a anode. It can be achieved by two ways. One is sacrificial anodic protection technique. Another one is a impressed current cathodic protection technique. In sacrificial anodic protection technique, what we are doing, one sacrificial anode is connected with the metallic part that is to be protected from corrosion. That sacrificial anode may be from zinc or magnesium or aluminum. What the sacrificial anode do? The metallic part to be protected, the nature of the metallic part to be protected is act as an anode. So what we are doing, the anodic part is converted to act as a cathode. How we can do this? By giving the connection to the highly active metal like zinc. Since the newly added active metal sacrifice its life for sake of protecting the metallic part to be protected from corrosion, this technique is called sacrificial anodic protection technique. And the advantages are there. Mainly the advantages of this method is it is a cheap method, and but then and there we have to periodically replace the sacrificial anode because it continuously loses its life. At particular time, it would be get over. So at that time, we have to replace a new metal there. That is the main disadvantages of this method. See this diagram. The pipeline is to be protected. This pipeline is given connection to the sacrificial anode. Here the magnesium is act as a sacrificial anode. See the electron flow happened from this sacrificial anode. So we can see that the electron flow towards the pipeline. So it is protected from corrosion. This is the main thing in the sacrificial anode. Sacrificial anode is a cathodic protection technique. In this, sacrificial anodes are used to protect the metallic parts. Zinc and aluminum, magnesium are used as the sacrificial anodes. That means they are acting as an anode by make the metallic part to be protected to act as a cathode. This is the principle of the sacrificial anodic protection technique. Next, we can see, go to the impressed current cathodic protection technique. In this impressed current cathodic protection technique, we are following the current connection, external battery connection. The limitations of sacrificial anodic protection is overcome in this method. Sacrificial anodic protection, we need to replace the sacrificial anode periodically. That type of problem will not occur in impressed current cathodic protection technique. It is shortly known as ICCP method. In impressed current cathodic protection technique, as you are seeing in this diagram, external battery is connected. See this external battery, and it is connected to the pipeline to be protected. The external battery connection is made in such a way that the metallic part to be protected is receiving the electron flow. That means it is converted to act as a cathode. This is the inert backfill, and it is made by the coke or magnesium. And the external battery circuit, it overcome the flow of corrosion current. The external battery current is little higher than the corrosion current, and the external battery current is flowing in opposite direction to the corrosion current flow. By the way, it cancel nullifying the corrosion current and protect the metallic part undergoing corrosion. The main thing in impressed current technique is external battery connection is given and the corrosion current is nullified by the external battery current. This is the main thing followed here. And here, as like in the sacrificial anode, no need to replace any part then, periodically. Just the current external battery is continuously supplying the current and it nullifying the corrosion current in the opposite direction. By the way, they are protecting the pipeline or ship hull, the metallic part to be protected from corrosion. So in this two methods, cathodic protection technique, one is sacrificial anodic protection technique, another one is a impressed current cathodic protection technique. In sacrificial anodic protection technique, active metals like zinc are connected to the metal part to be protected. So by the way, we are converting the metallic part to act as a cathode. So the overall principle of the cathodic protection is the anodic part is converted to act as a cathode. The drawback of the sacrificial anodic protection is then and there we want to replace the sacrificial anode. Advantage is the economically good. That is the cost-effective method. But impressed current cathodic protection is, since it involves the higher technologies, it needs some comparatively more cost we need, effective, efficient person also we need to run this technology, but it is more effective compared to the sacrificial anodic protection. And advantage, as I told you, that a little costlier than the sacrificial anodic protection technique, since it involves the external battery connection, and but it is more efficiency. It shows more efficient than the sacrificial anodic protection. This technique is extensively used in the transmission line tower, underground water pipes, oil pipeline, ship hull, everywhere.